This is Chapter 7, Lewis structures, homework question number 6A. Write Lewis structure for phosphate ion, PO4 3-. So first, again, let's find out the total number of valence electrons for this polyatomic ion. Okay, so total number of valence electrons. We have 1 phosphorus, so group 5A, 5 valence electrons. Oxygen is in group 6A, so each oxygen should have 6 electrons, and we have 4. That's 4 times 6. And now look at this chart, 3-, which means it gains 3 electrons. So therefore, that's that 3. Okay, that 3 comes from the charge. If you add them all together, that should give us 32 electrons. So if you take a look at the electron negativity, you will determine actually phosphorus is less electron negative than oxygen if you use the arrow diagram looking at a copy of periodic table. So, and there is also just 1, the subscript for phosphorus is just 1, even though it's not written. So it has to be the central atom. And then it should have bonding with each of the 4 oxygens. So therefore, we are talking about at least 4 units of bonds. So okay, then we place phosphorus as the central atom, and then the 4 oxygen, so as the peripheral atoms. And then, as I mentioned just a short while ago, between each phosphorus and oxygen, there has to be a bond. Okay, so whether single bond or double bond, so we'll determine that, okay, very shortly. So first, let's just write a single bond to each, okay? And then we'll assign the remaining electrons to the surrounding atoms. Make sure they satisfy the octet rule, for example. So for this oxygen, is already 2 electrons, okay? So from the bonding pair, from the single bond, so then we have 1, 2, 3, 4, 5, 6, then 7, 8. All right, we'll do the same. Okay, so and we'll do the same also for this one. Okay, so now, of course, you see, so far, for each oxygen, so do you see that? For each oxygen, that's a total of 8 electrons. Another 8, another 8, okay? So if I do this, then that will be also 8 electrons here. Then 4 times 8, that's 32 electrons. So bingo, then this should be the Lewis structure for phosphate ion. But that's actually not the case. Okay, now for the last pair of electrons, there are 2 ways of placing them. One way is like this one, as a lone pair attached to this oxygen. Okay, then we would have already used all 32 electrons. That's one way. Another way is actually we use them as bonding pair, which means we'll draw a double bond. Okay, that's also 2 electrons, you see? Now if you count as 1 single bond, another single bond, then altogether, of course, that's double bond. But each each line represents 2 electrons. That's 4, 5, 6, 7, 8. You see, for this one's 8, that's 8, 8, 8. That also satisfies the octet rule, and the total number of valence electrons is 32. Now the question is, so why did I not assign the last 2 electrons here as non-bonding electrons, as lone pair, we call that? Rather, so why not to do that? Why place the last 2 electrons actually here, forming the double bond? The question can be answered by applying formal charges. So we are going to talk about formal charges in the next lecture. So you can calculate the formal charge for each items in a molecule, or in this case, is a polyatomic ion. And then, so according to the formal charge values, we can determine which structure is more stable. In this case, so applying the formal charges, actually, we can determine this item carries a negative. This one, oxygen, also carries a negative. This one also carries a negative. You see, because they have each they have 6 non-shared electrons, which means those electrons can only be found around this oxygen. You see, so therefore the electron density is, of course, much higher compared with this one. All right, and with this arrangement, then the formal charge, after you calculate the formal charge, so this structure, I mean, assigning the last 2 electrons as part of the double bonds, so that will make the formal charge smaller compared with assigning the last 2 as a lone pair here without the double bond, just single bond there. So the formal charge will be higher there. So lower formal charge should be more stable. Okay, so that's why it will form actually this structure, with one double bond. So not the 4 single bond, and with 3 lone pairs surrounding each oxygen. Okay.